Hello everyone. Welcome to the solution of LeetCode problem 785 named is graph bipartite. In this problem, we are given an undirected graph and we have to determine whether it is a bipartite graph or not. So here, a graph is bipartite if the node can be partitioned into two independent sets A and B such that every edge in the graph connected a node in the set A and a node in the set B. So here we have to determine whether a graph is a bipartite or not. If it is, we have to return true, otherwise we have to return false. Now let's consider this example. Here the node 0 is connected to node 1 and node 0 is connected to node 3 and 2 also. 3 is connected to 2 and 1 is connected to 2. Now for this example, there is no way to partition the nodes into two independent sets such that every edge connects a node in one and a node in the other. That means it is not possible for this to become bipartite. But in the second example, this graph 0, 1, 0, 3 and 3, 2 and 1, 2, these connections, it is possible to make them bipartite because we can make 0 and 2 into one set and make 1 and 3 into another set. So it is possible to make two different sets. That's why we have to return true, as we are able to make this graph bipartite. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now, at first try to understand what is the bipartite means. Bipartite basically means a graph coloring. That means, suppose let's make the node 0 color red and we will make different color to its neighbor. So 1 and 3 will be colored green. Now, the neighbor of 1 and 3 which is not visited should be colored again to the alternative color red. So here, if we reorder this graph into this form, which is 0 to 1 and 3, we have seen that the node 0 and 2 will be in the red color and the node 1 and 3 will be in the green color. So 0 is connected to 1, 0 is connected to 3, 1 is connected to 2, and 2 is connected to 3. That means we have made this node similar to this node. So here, as this graph is exactly similar to this graph, and the first set of the nodes are in the red part and the second set of the node are in the green part, and as we have made the partition of the graph, so we can say that this graph is bipartite. But the question is, how can we solve this problem? Here, to solve this problem, we have taken two arrays. One is the color and another is the visited. The color will store the color of each of the node and the visited will store the true false. If one node is visited, it will store true, otherwise it will store false. Now, currently we are at this node 0. So let's initialize the color of the 0 will be 1 and make the visited of 0 which is true. Now from 0 we can go 1 and we can go 3. So here, as the color of 0 is 1, we have to make the color of the 1 and 3 alternative. So we will make the color of its 2. So here, currently, suppose we are at this position 1. So the color of the 1 will be 2 and we will make it visited. Now again, we are at this position 3. So color of the position 3 will be 2 and make it visited. Now we are at this position 3. It has two children, 0 and 2. So 0 is already visited, so we will not go there. Now we are going to the node 2. So here 2 is not visited. First make it visited. And as the color of the 3 is 2, so we have to make the alternating color here for the node 2. So the node 2 color will be again become 1. So here we have seen that we have to store the color value 1. Now we have seen that the color of 0 and 2 will be 1 and the color of 2 and 3 will be 2. And there is a connection between every pairs of node here. That means we can store 0, 2 and 1 and 3. And here 0 is connected to 1, 0 is connected to 3, 1 is connected to 2 and 2 is connected to 3. So here we have made the partition of the node 0 and 2 and 1 and 3 by using the bipartite algorithm. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named bipartite and it is given an adjacency list. Now, we are initializing the color and visited of size n, which is 0 and false. Now, for each of the node, if the current node is not visited, that means here we have to call our DFS function. For inside the DFS function, we are passing the current node, initial color 1, adjacency list, visited array, and color array. Now, inside the DFS, we have to store the color in the color array and make the node visited. Now, for each of the child, if the current child is not visited, that means here we have to make a DFS call and we have to use the alternative color, which is 3 minus column. And if the current DFS is returning true, that means the current graph is not bipartite. So which condition does this current DFS evaluate? If the color of child is equal to color of node. And here, if the parent color and the child color is same, that means it is not possible for a graph to become bipartite. So we have to return true. That means if this function returns true, that means it is not possible for us to become bipartite. Otherwise, we have to return false. Now, as this function is returning true, we have to return false because it is not possible for us to become the bipartite of this graph. Finally, after completion of this loop, if this return statement does not executed, we have to return true because now it is possible that our graph is possibly a bipartite. I hope you understood the algorithm and the code also. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.